Lesson 9.4, Solving Quadratic Equations by Factoring. So first, what does solving a quadratic equation mean? It means finding the x values where the equation would equal 0. Another way to say it would be we're looking for values of x that make f of x, the y value, equal 0. There's 4 different ways to name these solutions, and all of them mean the same thing. So I don't know why they created so many different words that mean the same thing, but for this, I'm not going to ask you to list these for me, but I need to make sure you know them so that if a question says find this and uses any of these words, you'll know what to do. So solutions is one of them. So find the solutions, find the zeros, the roots, the x-intercepts. Because where the function equals 0, that's also where it crosses the x-axis. So all 4 of these are the same thing. Now, just like there's 4 names, ironically, there's 4 ways we can solve it. We can solve it by graphing, which we looked at that in section 1, whereas if we have a graph, we can find the x-intercepts. Factoring, which is what we'll deal with today, how to solve by factoring. And then 2 we'll do later are completing the square and the quadratic formula. So you don't have to know what these 2 are yet. This is just me trying to give an introduction because we already touched on the graphing a little bit in section 1. We'll do factoring today, and then we'll do these 2 later. So just a reminder that quadratic means the equation has to have an x squared. Now it can be 2x squared or 3x squared or just x squared, but there has to be an x with an exponent of 2 or it's not quadratic. Sorry about that glare. Whoa. It's weird. I don't usually have a glare on this. Oh well. Now, to find the solutions or the roots of a quadratic equation by factoring, you need to follow these steps. Determine which type of quadratic equation you're solving for. Sometimes it'll just be x squared equals a number. Now it may say 4x squared equals a number or 5x squared equals a number. Or it could be in this form where it's got all the pieces on the left side, the constant and the x's, equal to 0. Now if it's of the first form, all you do is take the square root of both sides. Don't forget to include plus or minus when you do that, because anytime you take a square root to solve for a variable, you have to write plus or minus as part of the answer. If it's of this form, we've got multiple terms with x, or we've also got a constant, we want to make sure 0 is on one side. Then we want to factor the equation. Then we'll set each factor equal to 0. Then we'll solve for the variable in each factor. Okay, so I'm going to do one of each, then we'll do lots more of each. So right here, you can see this is type 1, so it's just x squared equals a number. For this method, you just take the square root of both sides. The square root and the squared cancel each other out, leaving just x. We have to put plus or minus in front of the answer, and the square root of 25 is 5. So I'll do more of these, but I wanted to start there. Now here's the other form. So let's talk through the steps again. Make sure 0 is on one side. Check. Factor the equation. Okay? So we know we'll have an x here and an x here. And we've got to think what will multiply to be 3 and add up to negative 4. Well, the only things that multiply to be 3 are 1 and 3. But to make them add up to negative 4 and multiply to be positive 3, we need to be negative 1 and negative 3. So x minus 1, x minus 3 equals 0. Because this is still an equation, it equals 0. So step 1, make sure 0 is on one side. Step 2, factor. Step 3, set each factor, so x minus 1 equal to 0, and x minus 3 equal to 0. Final step, solve for x. Here we just add 1 to both sides, and we get x equals 1. Here we add 3 to both sides, and get x equals 3. So there are two solutions here, positive 1 and positive 3. Just like there are two solutions up here, positive 5 and negative 5. There are times there may just be one solution, but there can be up to two solutions with a quadratic equation. Let's continue trying some of these that are the first type. Again, we know it's the first type because it's x squared equals a number. There's no x term. No term is just x to the first is what I mean. So we just take the square root of both sides. The square root and the squared cancel out, leaving just x. We have to put plus or minus, and then the square root of 49 is 7. Okay, number 3 is the same. We take the square root of both sides, because the squared cancels out the square root. So we get x equals plus or minus. And then you can do a fraction each part individually. The square root of 1 is 1. The square root of 4 is 2. So we get plus or minus 1/2. Here, we take the square root of both sides. We get x. And there is no whole number. The square root of 7 is not a whole number. So we can just leave it as the square root of 7. This is a more exact way to write the answer than giving the decimal form, so I'd prefer you just leave it as the square root of 7. Okay, now number 5 does give something a little bit different, because we don't just have x squared on this side. We also have a coefficient, 16. When that happens, before you take the square root, you need to divide both sides by the coefficient so you get rid of it. So we divide by 16 and get x squared equals 3. Now we're in the stage where we were in 1 through 4, where we just take the square root of both sides and get x equals plus or minus the square root of 3. Same scenario here. We need to first divide both sides by 9. Sorry about that. Then we take the square root of both sides. We get x equals plus or minus 1. All right, here we take the square root of both sides. And the difference with this one is we can actually simplify this radical. You get partial credit for giving me this answer, but if you recall, there are ways to simplify radicals if you can separate this into two numbers and one of them is a perfect square. So 8 is the same as 4 times 2, and we can take the square root of 4, it's 2, and we leave this 2 inside, so our final answer is plus or minus 2 square root of 2. Number 8, we divide both sides by 6. Take the square root of both sides, and we get x equals plus or minus 3. I'm very sorry. Number 9. So what's important back here in 1 through 8 is that we want to make sure the squared part is by itself, which for all of these, 1 through 8, it was just the x that was being squared. But when there's a coefficient, we had to move that over, so we had just x squared by itself. So as you look at 9, 10, and 11, you need to think with that same line of thought. What's important is that we get the part that is being squared by itself. So this is already in the form we need it to be. We don't have to move any coefficients out front. Everything is inside the parentheses. Everything we see, 2x plus 1, all of that is being squared. So our first step is to take the square root of both sides, because the squared and the square root cancel each other out. The square root of 4 is plus or minus 2. We do need to get x by itself though. So while on 5 and 6 and 8 we had to do some steps before the square root, in 9, 10, and 11 we'll have to do some steps after the square root. So I'll subtract 1 from both sides. And then I'll divide both sides by 2. So I would accept this answer, negative 1 plus or minus 2 over 2. That's a good answer. You could also, if you want to, split this up in two pieces and say negative 1 over 2, so negative 1/2, plus or minus 2 over 2, which is 1. So I am content with this answer and this answer. Either one would be accepted. Number 10 will have a similar path. Take the square root of both sides. The square root and the squared cancel out. Square root of 25 is plus or minus 5. We'll need to subtract 3 from both sides. And then divide both sides by 4. So our final answer is negative 3 plus or minus 5 over 4. Now I want to briefly anticipate a question some of you are asking is like, why am I putting this number in front of the plus or minus? Like, why am I writing negative 3 plus or minus 5 instead of writing plus or minus 5 minus 3? So let me just write some things up here just to show you, make sure we're on the same page. I'll do this one because it's a little bit simpler. So I'm just pulling this from what we were working on number 9. So when I subtract 1 from both sides, it is not wrong to write plus or minus 2 minus 1. It's just considered a little less clear what's going on because it can be easy to miss that plus or minus when it's out in front like this and right next to an equal sign. It can kind of get lost in the mix. Just visually, it can be harder for us to see. So it's not wrong to write it this way. I won't count off if you write it this way. But I am going to follow the pattern that most math books use. And when we add or subtract something over to the side, they put it in front of this number because that makes it more visible that we have a plus or minus going on. So that's why I'm doing it that way. And I'd recommend you do the same, but I would accept this and this. Okay, the last one in section 1, we'll take the square root of both sides. We get x plus 1 equals plus or minus the square root of 7. Then we subtract 1 from both sides, giving us x equals negative 1 plus or minus the square root of 7. Now back to type 2, where we have to factor. So reminder of the steps, we factor, we first make sure it's equal to 0. That's our first step. Then we factor, then we set each term equal to 0 and solve for x. So in 13, this one's already set equal to 0, so we need to factor. I gotta think what multiplies to be 9 and adds up to 10, and that would be 1 and 9. So I'll have m plus 1 times m plus 9 equals 0. Then I set m plus 1 equal to 0. Subtract 1 from both sides and get m equals negative 1. We'll take m plus 9, set it equal to 0. Subtract 9 from both sides and get m equals negative 9. So on number 14, this is where that's important step of making sure you're equal to 0 first. Because if you factor this, it's not that this can't be factored, it's this that you cannot then set them equal to 0, because these aren't equal to 0, they're equal to 5. And that doesn't work. This method only works when you're equal to 0. So my first step in 14 is actually to subtract 5 from both sides. Then I'm in the form that will work. So I need to think what multiplies would be negative 5 and adds up to negative 4. Well, 5's prime, so we know we can only do 5 and 1. So if we have a negative 5 and a positive 1, that will work. So x minus 5 times x plus 1 equals 0. Now I know this is early, but I would encourage you to see that it's not that hard most of the time to just right here say, okay, if I set this equal to 0, what number, if I plug it in for x, will make this equal 0? In other words, what minus 5 equals 0? 5. Same idea here. What can we plug in for x to make this equal 0? What number plus 1 equals 0? That would be negative 1. Okay, 15. Same thing as 14. We need to get this equal to 0 first. So I'm going to add 7p to both sides. I'm also going to subtract 15 from both sides. So I'm going to move both of those pieces over to this side. Get 2p squared plus 7p plus 15. And all that's equal to 0. So I'm going to use bottoms up. 2 times 15 is 30. I got to figure out what will multiply to be 30. I'm sorry, this should be a minus 15. My fault. So as we subtracted 15 from both sides, so that's 7p minus 15. So that means 2 times negative 15 is negative 30. So if we use a positive 10 and a negative 3, that will add up to 7. So I say p plus 10, p minus 3. But then that 2 we tried to ignore comes back. 10 over 2 reduces to p plus 5. This will not reduce, so we bring this 2 up top. We bring the bottom up and do 2p minus 3. So we set this one equal to 0, p plus 5 equal to 0. Subtract 5 from both sides, we get p equals negative 5. Set this one equal to 0. We add 3 to both sides. Get 2p equals 3. Then we divide both sides by 2. And we get 3 halves. You can also say 1.5. That's not wrong, but it's more common that they leave it in fraction form. Okay, 16. This one is set equal to 0, but this one is where we have to remember the first rule of factoring, which I didn't mention, but it didn't come up in the first 4, because you always want to factor first anything that both terms or all the terms have in common. Here, they're both divisible by 3, and they both have a b. So my first step is to factor 3b out. That leaves this with a b squared, because you divide by 3, so that cancels out to a 1. Take 1b away, so you have 2 left. 27 divided by 3 is 9. Take the b away, so it's just 9. And then this will become b plus 3 and b minus 3. Now this one did not start as a quadratic. That's the only reason this one can have 3 answers. But a mistake people commonly make is they'll pull the 3b out, but then it somehow disappears and they forget about it. Don't do that. You have 3 terms here. So if you set 3b equal to 0, you get b equals 0. Set b plus 3 equal to 0, you get negative 3. I'm going to have to hire an editor just so I can get all that out of there. All those coughs out of the video. Anyway, set b minus 3 equals 0, we get positive 3. So those are the 3 answers for number 16. Last one. This one is set equal to 0, and it's already factored for us. So don't be deceived. This is a lot easier and quicker. You may be like, this doesn't look like any of the other ones. That's true. But in this case, it's because they've actually done lots of the work for us. All we have to do is set 4k equal to 0, and we get k equals 0. Then we set k plus 5 equal to 0, subtract 5, and get k equals -5. So 0 and -5.